All right, time for another DraftPhysics.com, debatephysics.com also, video presentation. Kind of a out of the ordinary video, Veritasium video, and it was just so poorly titled, and the whole thing seems like it's going to be just such a piece of steaming crap. I said, well, I got to play this stupid video, so I might as well do a reaction video, so I will. It's titled, "We Might Find Alien Life in 2,326 Days." So apparently some stupid probe is going to one of the stupid moons of Jupiter, I think, and looking for life. So he could have just bought a lottery ticket and then titled the video, "We might win $1 billion in 2,360, whatever days." I mean, it's just bullshit. The odds of there being life on a planet is just so tiny, in the sense that we've already done the experiment on Earth, and it's clear that whatever this thing is, it doesn't happen a lot of different ways. It just basically happens one way. And there's just no evidence that you can vary the circumstances in any tiny little bit, and it just doesn't work. If something called life was to generate in some little nook or cranny of Earth and be made out of something different, it doesn't take much for it to survive and for it to, evolve into something that can survive competing with us. And it would be playing the game, and it's not playing because it never was. And it just isn't. It's just not a reasonable thing to believe. It's clear it's very rare chemistry that creates a replicating DNA molecule, let alone all the stuff that grows out of that. All of that isn't too likely either. So anyway, we'll play the stupid crap video. Okay. I'm just selling crap to stupid humans. I mean, this isn't science. This is just crap. There's very little prospect that you're going to find a living organism, especially under the circumstances. When you know that part of this living thing is the warm environment. And without the warm environment, the whole thing grinds to a very improbable halt. All right. So let's play the video. And I'm so sick of bullshit.
Arthur C. Clarke had a sequel to 2001: A Space Odyssey. It's called 2010 Odyssey 2.
Oh, good. Nobody watched it. I never saw it. It must have been really horrible. Did they make the movie? I don't know. Did they?
At the end of it, an alien intelligence converts Jupiter into a star. As a group of astronauts narrowly escape the implosion, they receive the following message from the aliens: "All these worlds are yours, except Europa. Attempt no landing there."
So whatever that even means. Okay, so the aliens made a star really close to their planet, and how could you even land there if the damn thing's on, a sun? Oh, well, whatever. I'm not even going to bother thinking about it.
Now, that was just a novel, but it's a...
Yeah, and nobody made a book out of it. Good. Because frankly, that movie wasn't all that. I mean, except for the little great opening scene with the monkeys, God, a tedious, whatever it was, 5 hours.
Just that already in 1982, we suspected that Europa might offer our best chance of finding alien life in our solar system.
Right, so it's basically frozen on the surface, obviously hot in the center, right? And that's the whole gravity thing that they still haven't figured out, that gravity is creating real energy in the universe, okay? The bent space is making real energy, and that has to be accounted for. As you can't just make this argument that it's a bent geodesic. It has to be made out of some kind of real force stuff.
42 years later.
Oh, you don't have any conservation, of course. All right, so 42 years later, we still got, people still don't understand that physics tells you that thrust coming out of the engine, you can calculate its kinetic energy. And the fact is that its kinetic energy of the thrust is not going to equal the momentum of the rocket. So that is the mv squared of the rocket will not equal the mv squared of the thrust, and therefore violating Newton's third law. But they won't tell you that. But the truth is the momentum of the thrust will equal the momentum of the rocket, and that will be consistent with Newton's third law, and will be conservational, of course, and will make a lot of sense. But they don't, they'll just lie and pretend their physics has got its right answers when obviously it doesn't get right answers.
In October 2024, NASA is actually launching the most advanced mission to hunt for signs of alien.
No, in October. Well, it's already past October. Oh, it was done 3 weeks ago. So he did the video before they launched it? Interesting.
In life. And it's going to Jupiter's moon, Europa. There's just one problem. Jupiter kills everything around it. So how could life even exist there? And
what does that even mean? Okay, Jupiter kills everything. There's nothing to kill. There's no living things to kill. So that doesn't even make any sense.
how do you make a probe that can withstand the perilous conditions?
So we already did. I mean, we sent those Voyager things out there, took all kinds of pictures. And again, you're so close, you should be able to do the lensing thing. You should be able to do the Eddington experiment and prove that light is bent by gravity. But they won't do any of that.
Deep inside Jupiter, there is so much pressure that hydrogen is believed to take the form of a metallic liquid.
Okay, so again, so much pressure. It's less pressure than the sun, obviously. But yes, what's all the pressure creating? What's pressure create? Oh, that's right, heat. Yeah.
And this metallic liquid hydrogen generates an incredibly powerful magnetic field, almost 20,000 times stronger than Earth if you measure at the same distance away. So if you could see this magnetic field from Earth...
Same distance away from what? The center or from the surface? He didn't say.
It would appear twice as big as the full moon. On its own, that magnetic field is harmless.
Yeah, okay, so it's sort of the joke, right? That even if it was 1 million times stronger than the Earth's magnetic field, the Earth's magnetic field is so weak that, you need it to be 1 million times more to be even interesting.
But right in the middle of it is the most volcanically active world in the solar system, Jupiter's moon, Io. The volcanoes on Io's surface shoot out tons of sulfur dioxide, and every second, 1 ton of this material gets ionized and trapped inside Jupiter's magnetic field. And the field...
All right, so the argument is it's dirty. Okay. So again, the Voyager probe handled it okay. So I guess, maybe they're going to get even closer or something, and that's why this is somehow going to be an issue. That they have to travel through a bunch of dirt.
Accelerates these particles to rotate incredibly fast with Jupiter, so they whiz around at over 300 kilometers per second. Their inertia actually pulls back on the field, stretching it out, and this trapped material slams into other moons, ejecting even more particles from their surfaces. There's no inertia, so he's just basically talking about the fact that their velocity is higher than their orbit, so they spread out. They are increasing their orbit. Cycle forms massive radiation belts which span past Europa and the other moons of Jupiter. Now for electronics, this intense radiation is kryptonite. In the 1970s, the Pioneer 10 and Voyager missions
There you go.
only briefly passed by Jupiter, but the radiation caused glitches, gave the instruments false commands, and corrupted some of their data.
Well, now that you know about it, you can put up your little shields, your Faraday cagey thing.
Even with modern shielding, a spacecraft within the radiation belts would only survive for around 3 months.
So what's it need to do that's going to take 3 months to do? You would wonder, right? What's it need more than 3 months? What is it going to do, right? I mean, there's nothing to do. It's going to take its pictures, do its analyzing, there, it's done. What does it need 3 months for?
So how will NASA's new mission, the Europa Clipper, orbit Europa for over 4 years without getting fried? Well, the solution is it won't. It'll orbit Jupiter from afar and then swoop in every few weeks to quickly fly by Europa and then leave again. And since the mission is going to collect a lot of data, it can use the downtime while it's way out here to transmit it all back to Earth before going in for another swoop.
They're just going to drag it out. What's the point? They're just dragging out the 3 months into years, and it's really not going to save all that. Their ability to transmit data, I don't think, is that feeble.
In all, it'll do 49 flybys, mapping almost the entire surface. That's actually how...
Oh, how exciting. I think we already saw the surface. I don't know what. We've probably seen almost all of the surface.
The Clipper got its name after the fast and nimble 19th century clipper ships, quickly dipping in and out of ports. But of all the places in the solar system to look for life, why Europa? If you stood on Europa's surface, you'd be hit with 5,400 millisieverts of radiation in a single day. That's 1,800 times more than the annual dose here on Earth.
Yeah, and maybe it don't mean that much if you evolve with that circumstance. But yes, that's the wrong kind of heat.
If you stay here for a couple hours, you would eventually...
I mean, it just destroys the stability of all chemistry. So any chemistry, including reproducing chemistry, isn't going to do very well when it's being irradiated.
Eventually die from radiation sickness. But Europa contains a secret. When Voyager 1 passed by Jupiter in 1979, it took this photo of Europa. If you compare that to most of the other moons in the solar system, you'll notice something is missing. Craters. Every planet and moon has been bombarded by asteroids over billions of years, and most planetary surfaces show it. But not Europa. So why not?
Because it melts constantly.
Well, something recent, say over the past 60 million years or so, must have been happening on Europa to erase most of these craters from the surface. 16 years after Voyager, Galileo arrived to Jupiter. It spent 8 years studying both the gas giant and its moons. And Galileo's magnetometer picked...
8 years? I didn't know it circled around there for 8 years. 8 years and it didn't do the Eddington experiment?
Up something interesting on Europa. Jupiter's magnetic poles, like Earth's, aren't aligned with its geographic poles. So as the planet rotates every 10 hours, the whole magnetic field wobbles.
So 10 hours is pretty fast. So yeah, it's really moving. For a big planet, that's very fast.
This changing field from Jupiter induces a magnetic field on Europa, and a relatively strong one at that. That means there must be an electrically conductive layer within Europa that reacts to Jupiter's field.
So again, they keep speculating about the formation of these fields, and they're really can only be realistically understood as being created by some kind of iron-like material. And that's really all you're doing is just, magnetizing the iron.
And readings from Galileo indicate that it must be somewhere close to the surface, only tens of kilometers deep.
That's all weird, but whatever.
So what kind of conductive layer? Well, Europa's white surface is almost entirely covered in a thick crust of water ice. These reddish-brown regions, when observed through a spectrometer, fit the description of a lot of things, like hydrated salts, sulfuric acid, or even bacteria.
Or even rust, but go ahead.
We need more data to be sure, but recent experiments at JPL found that sea salt, when bombarded with intense radiation, turns from white to this same brownish color found on Europa.
Oh, there you go, salt.
So scientists suspect that there's a whole saltwater ocean inside Europa. It could be 100 kilometers deep, meaning Europa would contain twice as much water as the whole of the Earth. And it must be driving geological activity that constantly smooths out and renews the surface of the moon. But the Jupiter system only gets about 4% of the sunlight we get here on Earth. So Europa's surface is constantly below negative 160 degrees Celsius. So
yeah, it's pretty cold. Need a break. All right, we're back. So far, not very interesting. But anyway, so a minus 160 on the surface. It's going to get warmer as you go deeper. And it's shielded from all the radiation down there. But so what? Yeah, there's no reason to think there's a bunch of living stuff in there.
You'd expect the whole ocean to be frozen solid. But there's a way to generate heat that doesn't rely on the sun. And I've got a little demo here.
Oh, brother. So obviously the core of the planet is, the moon is hot. So it's just, the heat just radiates out to the surface. Everything has to radiate what goes in. And there's a ton of stuff going in, converting a bunch of pressure, a bunch of compression, and all of that heat exists. And so, yeah, it's not the kind of heat, on the surface. There's, the core gets a temperature, 1,000 degrees. Well, as you go further and further out, there's more and more mass. So the temperature obviously goes down and down and down and down. So the more mass there is for the core to get to the exterior, depending on how heavy the planet is. Now, if there's a lot of water on the planet, then, it's not the most massive element in the periodic table. So, oxygen and hydrogen, it doesn't add up to nearly as much as, lead or something. So it doesn't contain as much of the heavy elements. So its mass isn't as high, so its temperature isn't as high. But what they really should do is study this temperature thing, because the temperature thing is really telling you exactly how much external pressure, heat, there is in space. You could say a cubic meter of space contains a certain amount of heat, because all of the objects are going to be hot, completely proportional to their mass.
To prove it, Europa's orbit around Jupiter isn't
So it looks like a pretty crappy experiment coming up.
a perfect circle. This is because Io, Europa, and Ganymede are all in orbital resonance. Each time Ganymede completes one orbit, Europa completes 2, and Io 4. Because of that, Io tugs Europa inward on one side of the orbit, while Ganymede pulls it out on the other, making its orbit more eccentric. Now, Jupiter's pull is stronger on the closer side.
So why would this be a big surprise, in the sense that most orbits in the solar system are parabolas, right? Is that what they call it? Yeah. Anyway.
Of the orbit than on the farther side. So Europa is constantly being stretched and squeezed, stretched and squeezed.
Right, and the Earth is getting stretched and squeezed by the moon. And frankly, the other planets and this, and all that stuff happens, but that's not what's heating the planet. So again, this is all sort of bullshit. So is their argument really that the core of the planet is 0 degrees? What's their argument? Or does it get hotter and hotter the go deeper you go? Everything gets hotter the deeper you go, because there's more and more pressure. Pressure creates heat.
And you can see how this rubber ball gets warmer as I squeeze it.
You can? Yeah, I don't know. What a bullshit experiment, right? You don't push with a warm thing on the rubber ball, right? You take a piece of wood or some other kind of thing that is thermally neutral, doesn't get hot very fast. Um, you don't push it with your frickin' hand. Just bullshit. I mean, his hand is going to get hotter. So, of course, the ball is going to get hotter just because his hand is going to get hotter.
Scientists believe that the friction
Oh, that is just so bad.
caused by the tidal flexing of the entire moon can generate enough heat to keep the ocean liquid. This
Okay, so who says so? That sounds a little thin, right? I mean, it's very gradual motions. Yeah, it's a lot of mass going to move, earthquakey kind of stuff. But it's not the kind of stuff you think of as being the kind of motion that's going to have, all that little jiggly stuff. That's the jiggly stuff that creates a lot of heat. The idea that the force of gravity is pushing from all directions towards the center and there's no cancellation. All of that energy has to either come back out of the planet eventually. And, all of that conflict has to be resolved with the players ejected from the planet.
effect gets stronger the closer you get to Jupiter, which is why Io is so volcanically active. So you can see this ball is significantly hotter now. I held onto this ball at the same time to make sure it wasn't just the heat coming in from my hand.
Oh, yeah, sure. That's very scientific.
What sort of temperature of the ocean are we thinking?
So it depends on how salty it is. So melting temperature of ice, or maybe depressed by 10 degrees Celsius below that if it's a very salty ocean, similar to cold oceans on Earth.
And how would the flexing differ if there's this big liquid ocean versus if there's no ocean there?
If there's no ocean, Europa should flex by only about 1 meter in amplitude. But if there's an ocean in there, then it flexes with an amplitude of 30 meters. So that's an enormous deflection, and that will come out pretty clearly in the gravity data.
The gravity data. I would imagine that would be more like sonar or radar or something. I mean, how are you going to detect how fat the planet's getting? Oh, dear. Doesn't sound very realistic.
Another argument for how thick the ice shell is, we see these very strange features on the surface that are arcuate in shape, but like multiple arcs put together. We call them cycloids, and not something you'd expect to see on an icy moon. And we think they form if a crack propagates at just the right speed, about the speed someone would walk, and is following the changing stress field of Europa being squeezed as it orbits around Jupiter. And if there were no ocean down there, there wouldn't be enough of an amplitude of that motion to explain the cracking. But if there is an ocean, then it could explain the cracking.
Okay, so it's all just speculation based on little scant bits of information. So, but what does this have to do with the title? Why should I expect there to be life on Europa?
All that tidal flexing pushes magma in the outer core up, closer to the...
So again, so they're conceding that, well, wait a minute, after the 100 miles of ocean, there's magma, and the magma doesn't heat the water? That would be rather spectacularly strange to accept that as a theory. And then if that happened, wouldn't that create a bunch of gas that would end up getting to the surface and bust holes in it and leave scars?
seafloor. Water flowing through the crust above it is heated and it picks up minerals from the ground, ejecting them into the ocean. This creates hydrothermal vents. And
yeah, on Earth. So again, the pressure is much greater on Earth, okay, the gravitational pressure, which ends up being, the pressure of the weight of the water. So, on Europa, if, the deeper you go, I mean, it's a small planet. You got 100 miles. I don't know how many miles across the whole thing is. So what are you talking about? Maybe you'll end up being, well, you still have all the water above the center. So it's still sitting on the center's head. So it still gets higher and higher pressure the deeper you go. It's just not as high a pressure as Earth.
Where we find these on Earth, we also find life. Thousands of meters below the surface with no sunlight, these vents are oases for ocean life. The life forms down here rely on unique bacteria.
Right, but it's all the same DNA. So let's just understand it's whether life started there and, traveled elsewhere or vice versa, it's still one DNA molecule. And that's it. There's no other variety of alive stuff. So all these places where this could happen, all these vents pop into existence, and there's just no evidence that they produce some competing molecule that's capable of replication.
Bacteria that feed on the minerals from the vents rather than from the energy provided by the sun.
How long are we thinking that Europa has had an ocean?
It could be 4 billion years. We don't know for sure.
That amount of time could give life the opportunity to evolve.
Right, so they still haven't told us what the realistic temperature ranges are here. What's realistic?
Those oceans.
Right, exactly right. Organisms can use methane, carbon dioxide, sulfur reactions, any chemical reaction you can think of that might happen in the ocean.
Yeah, well, it's not about feeding it. It's about creating the replicating DNA in the first place, some kind of molecule capable of replicating itself, and that's a complex compound. And you still haven't explained how you're going to build that.
Can potentially.
I mean, to do the evolving thing, it has to be a very complex, made out of elements, but it has to be a very big molecule, capable of being very long, or very fat, or very something, so it can carry a bunch of information. So it has to be something proteiny, all right? And that just doesn't poof into existence.
Be used as a fuel for that organism's metabolism. So we're not talking about searching for fishes or whales or squids or something down there, but looking for single-celled organisms.
We were...
Yeah, and again, single cells, what? Nucleic cells, non-nucleic? It just, again, the whole idea of the molecule had to somehow, through its evolution, through somewhere in our history, it went from being just a DNA molecule to being a DNA molecule with a cellular wall. Another big leap.
So concerned there might be life on Europa that when the Galileo mission was ending in 2003, it was deliberately crashed into Jupiter to avoid the risk of contaminating Europa.
Oh boy, that's funny. Jesus. Yeah. Yeah, I didn't know they crashed it into Jupiter, so man, I learned something. So this Galileo thing spent years, and how come it didn't take any better pictures, especially, like I said, the Eddington-style pictures?
But Clipper will not be able to drill through the kilometers-thick ice crust. So how are we going to find evidence for life beneath that thick surface? This is the Snotbot. It's a drone with petri dishes glued to the top, and it flies right through whale blows to collect whale snot right here on Earth.
Wow, that's fascinating.
And zoologists can use the Snotbot to retrieve all sorts of info on a whale's biology. And it turns out we can do something very similar for celestial bodies too. We've actually captured images of water geysers shooting out of Enceladus, a moon of Saturn, housing a subsurface ocean. And
So again, but they can't repeat the Eddington experiment from space.
the Hubble Space Telescope has picked up some evidence of what could be similar geyser eruptions on Europa. The hope is that Clipper could fly through one of these plumes like the Snotbot and reveal their chemical composition using a mass spectrometer.
Well, this seems very low likelihood kind of event.
But evidence for an ocean on Europa isn't conclusive. Enceladus seems like a stronger candidate. We have actual images of its plumes, and we've even flown through them. We are almost 100%
So what are we doing this for?
certain there's a subsurface ocean there.
If we have these plumes on Enceladus and there's clearly maybe a liquid ocean there, why does Europa have your attention more than Enceladus? Is there something that draws you?
We don't know how long it takes life to get going, but it's possible that Enceladus may have just kind of started up its engines, whereas Europa has more likely been well.
So what they're saying? One of the moons is older. What a pile of shit! Yeah. Oh, come on. The universe is, the solar system has slowed down and it's cleaned out and it's been, cleaning the dust out of itself for, billions of years, 4 billion years, and nothing's doing any new song and dance.
Evolved over a long time.
Surprisingly, being bombarded by Jupiter's radiation actually makes Europa a better candidate. See, those high-speed particles hitting Europa's surface give water and carbon dioxide molecules enough energy to form new compounds, like formaldehyde or hydrogen peroxide, and these can serve as food for life beneath the surface.
Right, but it doesn't have any evidence of that, right? Because it's just kind of one color except for the going rusty or whatever. So it's not doing a whole bunch of colors like Jupiter. It's not demonstrating that it has a bunch of chemistry happening because the chemistry would have a different color. So that argument sort of fails. Yeah, I should point out, they're going to precisely navigate this probe to get it there and do these things. And all that navigation requires them to eject gases and do other things to create thrust. And that thrust is always going to be calculated using momentum, because momentum is what creates the equal and opposite reaction in the probe or the satellite. And if you calculate the joules of energy coming out and assume that you're going to get the same joules of energy in the other object, that the third law applies to kinetic energy, well, they'll fail. And the only way you'll succeed is if you obey Newton's physics and use momentum. And they should say that. They should just point out that this is another example where kinetic energy plays no role whatsoever in understanding the physics, that allows you to do these things.
If they can get down that far.
And we have evidence of overturn of the icy shell at chaos zones where the icy crust seems to have collided and material has been shoved into the icy shell. So there may be...
So they got the plates. Let's see. Subducting plate, denser and deeper, warmer ice. Warmer ice. That's an interesting statement, isn't it? The warmer ice.
Ways for this fuel for life to get down into the icy shell and potentially to the ocean.
And Clipper doesn't...
So again, he's talking about a fuel for life when, the fuel is, like I said, that can be made out of almost anything because, frankly, there's nothing stopping a living organism from being able to eat radiation. I mean, there's no law against it. So anything that generates any kind of heat, it could use technically as fuel.
Have to touch down on the surface to confirm this.
There's a infrared spectrometer to look at the chemical fingerprints of light bounced off the surface to help identify and map out where the salts are, find if there are organics there. There's a ultraviolet spectrograph that's aboard the spacecraft to look for plumes. Are they there? And of course, then can we fly through them? And then there'll be imaging of essentially the whole globe at better than 100 meters per pixel resolution. So
100 meters per pixel. Well, shit, that doesn't sound too good.
Camera will take swaths of images as we fly over the surface, and that's called the wide-angle camera. And then the other camera is the narrow-angle camera. From 50 kilometers altitude, it will get half meter per pixel images.
Half meter per pixel. So it's, again, that isn't 1 pixel for, the size of a person. That's, you're not going to see much in terms of real features.
Right, so it'll be able to resolve my desk here if it were on Europa. And then it would be a future
Barely.
mission, like a lander, that would go and actually search for signs of life at Europa.
Oh, brother. So the lie is that this one isn't even going to search for anything. And so it has everything to do with finding alien life.
Do you think a lander would have a chance of survival?
There have been studies that say we can get a lander living on the surface for a month if we think that's sufficient to go in there, scoop some stuff up from below the depth of radiation processing and put it into a mass spectrometer and see what we see.
But the Europa Clipper won't be studying Jupiter's moons alone. The European Space Agency's JUICE mission, or the Jupiter Icy Moons Explorer, is already on its way to Jupiter. It will
So again, and they do these, why don't they do the Eddington experiment? 5 minutes,
come to the system just 15 months after Clipper, and it'll even be doing a few flybys of Europa before settling into a tight orbit around Ganymede.
So the European Space Agency will also have a mission there at the same time?
Yes, we're having informal conversations with members of the DraftScience team. What would it mean to have 2 spacecraft there at the same time? The JUICE mission will end up in orbit around Ganymede, and Ganymede has its own magnetosphere. Well, we'll be outside Ganymede's magnetosphere, so we might say, oh, look, there's this big burst coming from Jupiter, and then JUICE might say, oh, we felt that over here in our magnetic signals. So we wouldn't have to really do anything different except talk to each other and make sure that the sum of the whole is even bigger than its parts.
Europa Clipper was scheduled to launch on October 10th, 2024, but NASA is waiting for Hurricane Milton to clear Florida before the spacecraft can take off safely.
When will we get the first results?
You'll start seeing distant observations coming in 2030 as we look at Europa from afar. And
2030?
search for plumes, and then you'll see the first really high-resolution data in 2031.
So after, say, 26 years of thinking about a mission to Europa, how does it feel to be so close to launch?
Oh, brother. Mush. All right, let's just finish this.
It's a little surreal, I must say. This has been such a long time coming. It's occasionally hitting me that our spacecraft is going to be up there in the heavens, right, on its way.
Yeah, it's probably going to something will happen. Blah, 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 blah.
It turns out that during a Europa Ocean conference in the late 90s, NASA actually video called Arthur C. Clarke, and after showing him plans for a future mission to explore the faraway ocean world, Clarke finally gave NASA permission to land on Europa.
That was just terrible. All right, so that was a waste of time. Let's see what he's still going to make a little speech.
Europa?
Yes, it was clickbait. That's right. The video was clickbait. I'm just talking shit. This doesn't have anything to do with it. They're not going to find anything that's going to prove anything about life or any of that crap. I just made all that shit up.
Europa Clipper is a perfect example of the amazing things we can do when we set ourselves ambitious goals and then work together with others.
Yeah, why don't you get ambitious and drop 4 pounds 1 foot and 1 pound 4 feet and see how big a dent they make on Europa. Yeah, okay, why don't you do that? Oh, fuck.
Others to achieve them. But I think we often get wrapped up in our everyday lives and forget just how much of an impact we can make on the world.
Oh, so he's selling crap, disguised as some sort of candy.
That's true on a society-wide level, like these big international space missions, but I also think it's true at an individual level. You yourself can probably accomplish much more than you think when it comes to making the world a better place. And today's sponsor, 80,000 Hours, wants to help you do just that.
Yes, they paid me to say that. Yeah. How many hours do you have to think about that before you say, gee, that's kind of slimy, isn't it? You're just saying this shit because they're paying you to say this shit? Gee, should I trust you? I don't think so. So anyway, fuck this. Yeah, so fuck this. Till the next time and such. So all the commercials ain't worth it. You know, I can't make enough money from Patreons and volunteers and all this other crap. Millions of views, and he's got to still sell shit. Because he wants more graft out of the science. What's science done for you? Yeah, right. Shit. I just hate this planet. So anyway, kind of a waste video, but I didn't think it was going to go anywhere. It wasn't even a good scientific. He didn't even talk about abiogenesis and all of the events that appear to be one-time events in our evolution. All of the events that have to take place in this chemical mixture to get it off the ground so it can even start to evolve, let alone ever evolve a neuron. One-time event. One single organism made an electrical cell. One. All the rest have failed to create that mutation. Alright, anyway. Till the next time and such. And so forth. And what?